Okay, so we're going to take a look at a specific type of sequence called a geometric sequence. We're also going to be looking at a geometric series in section 9.2, so you're going to see this exact same form come up again. All right, so a geometric series is defined merely by this r to the n. Okay, so some sort of constant raised to the nth power. It can also be multiplied by a generic constant out in front, so some sort of c times r to the n. So knowing that that's what a geometric sequence needs to look like, we're going to look at question 21 and we're going to identify which of these are geometric sequences. All right, so the first one is -1 times 6 to the n. So I definitely have a constant raised to the nth power, so that's a good sign. That would say that my r is equal to 6. And it's being multiplied by a -1 out in front, so that -1 is my c. So I have c is -1, r is a 6, is raised to the nth power, so this is a geometric sequence. All right, letter B has 5 times n squared. So in this one, the n is in the base instead of the exponent. And for a geometric sequence, we need the n to be in the exponent. So this is not a geometric sequence. All right, moving on to letter C. So here I have 1/3 raised to the n minus 1. Okay, so we're close. I have a constant, and I do have an n, the exponent, which is a good sign. This is also a geometric sequence. So as long as I have an n up in the exponent, I am going to be okay here. So I could have n minus 1, I could have n plus 3, anything like that, as long as that's just this an n adding or subtracting something. It's also okay if you had like 2n, that would still count as a geometric sequence. So this is geometric, and so here the 2 out in front is our c, and the 1/3 is our r. All right, and the last one, letter D, I have 5 times -1/2 to the n. So this is a good sign that I have a constant raised to the nth power. Okay, so that would make this -1/2 my r. And that's okay. It's okay to have a negative r. That's totally fine as long as it's raised to the nth or n minus 1 or n plus 2 or something like that. And then this 5 out in front is my c. So this is also a geometric sequence. Okay, so we're going to go back up and define a little bit better what this r is and how it works in finding the terms in the sequence. So the r is known as the common ratio. Hooray, I managed to spell it right this time. It's only my 5th take on this video. So got that right. And then the way that we find each term in the sequence is we multiply it by r, and that gives us the next term in the sequence. So for example, if I was looking for the n plus 1 term, I'd take the nth term and multiply it by r. And this relationship is really helpful because we can rearrange it so that I have the n plus 1 term over the nth term is equal to r. So if I have 2 consecutive terms in a sequence, and I know that that sequence is geometric, I can find r just by dividing the 2 consecutive terms. All right, so we're going to try this out on numbers 22 through 24. So I can pick any 2 consecutive terms, so I could use the -1 and the 6 and the -36, the -36 and the 216. It doesn't matter as long as they're consecutive terms, and I put the term further in the sequence, the n plus 1 term, over the nth term, the term that comes before it. So in this case, I feel like using the 216 and the -36. So r is equal to 216 over -36, and if I pull out my trusty calculator, that's going to come out to be -6. Okay, and then number 23, if you printed out these notes before I made the correction, that 1 over 32 should be a 1/8. Otherwise, this is not a geometric sequence. So if you have the older version, cross it out and put a 1/8 there. And then I'm just going to pick 2 terms. So let's do the 1/2 and the 1/4. So the 1/4 is the term further in the sequence. So I'm going to do 1/4 divided by 1/2. Okay, so that is 1/4 divided by 1/2, which is 1/4 times 2/1, which gives me 2/4, which is 1/2. Okay, so I get my common ratio on this number 23 is 1/2. All right, and then I would like you to try number 24 on your own. So go ahead, pause the video, give it a try. As Smokey says, only you can pause the video and give it a try. All right, so let's go ahead and do this one together, see if we got the same thing now that you've given it a try. So just going to pick two terms. Let's do the -4 and the 20 that are adjacent to each other. So I have r is equal to 20 over -4, which gives me a -5. So I hope that's what you got. If you did, you're on the right track here.